Welcome to Emergency Power Lab. Today we are looking at something you may have already seen online. A solar panel labeled as 100 watt. And then you notice the size, about 30 times 25 centimeters. At first glance, that can look impressive. A small panel, high power. It feels efficient, modern, almost advanced. But if we don't understand the numbers, this kind of listing can be misleading.
Very often, the large number appears in the product title. But if you scroll down, the story can change. Here, the specifications say the operating voltage is 5 volts DC and the output is dual USB, 5 volts to 0.4 amps max. Even if we take the simplest interpretation, 5 volts times 2.4 amps is about 12 watts. And even if someone argues it could be per port, that would still be about 24 watts maximum. Either way, it's nowhere near 100 watts. That's a big difference.
There is one important detail here. Sometimes seller lists open circuit voltage and short circuit current. These two values do not occur at the same time. Multiplying VOC times ISC do not give real power. So if you ever see those values presented like that, be careful. But if rated power is given, or operating voltage and current, the math is straightforward. Today, let's ignore product listings. Let's ignore marketing and ask a simple physics question. Can 100 watts realistically come a surface this small? To answer this, we only need two ideas. First, how much sunlight reaches the Earth. Second, how efficiently panels convert it. Under standard test conditions, sunlight is defined at about 1000 watts per square meter. This is not everyday weather. It's a laboratory reference, a comparison baseline. If you want the full context of what STC actually means, I covered that in my previous video.
Now let's look at the size in this listing. It says 305 by 250 millimeters. That is 0.305 meters by 0.25 meters. So the panel area is 0.305 times 0.25. That equals 0.076 square meters. That's the entire surface. If 1 square meter receives 1000 watts, then 0.076 square meters receive about 76 watts. That is incoming sunlight, not electrical output, just raw energy from the sun. Solar panels are not perfect. Modern silicon panels are about 18 to 22% efficient. In simple terms, about 1/5. So we multiply about 76 watts by 0.2. That gives about 15 watts, under ideal reference conditions, not 100. Even with optimistic assumptions, we might get something like 15 to 20 watts, but not 100.
To get 100 watts from this surface, the panel would need to convert more energy than reaches it, but violates conservation of energy. In simple terms, it's physically impossible, or at least with our current understanding of physics. Let me show a real reference. This panel is about 42 times 34 centimeters. That equals 0.143 square meters, and it's rated at 20 watts. Now the relationship makes sense. More area, more sunlight, realistic power. The same applies to real 100 watt panels. They are much larger, typically half a square meter or more, sometimes even larger. Not amount of area can realistically collect enough sunlight to produce 100 watts under standard test conditions. The numbers match, the size matches, the physics matches. This is not about accusations and not calling products fake. It's about understanding limits. Whenever you see a panel listing, ask one simple question. How much sunlight can physically hit the surface? This is Emergency Power Lab. Thanks for watching. I'll see you in the next video.